Not quite that close together. Alright, Crewton Ramone's House of Meth. So, we got the idea from a friend of mine who's the librarian at my old high school. Put up this article that talked about doing stuff together with your kids on the internet. So we might make a blog. It'll be you guys. And
it's called JulianMarcus.com.
JulianMarcus.com? I don't think so. What are we going to call it? We have to come up with a name for it. But it'll be like a math blog, but it'll have more than just math on it. It'll have whatever you guys like and stuff on it.
I like dinosaurs.
It'll have dinosaurs. Definitely have dinosaurs.
Trapmaster.
Trapmaster, okay.
You can play the
crazy
game on
video
our
game.
website. Yeah.
Oh, that might be an idea.
Do not say that again.
Okay, so anyway, we could have all kinds of stuff, math games, and we could have videos of you guys doing math.
A video game.
Like this one right here. Okay, so look forward to that. That might happen in the near future. So here's what I want to do. Ben Isaiah, x plus 2 times x plus 2. Tell me the whole rectangle.
X plus 2 times x plus 2.
What do we have? And you build it real quick.
4x squared, 4x, and 4.
Very good. Very, very good. See any symbols? Oh, look, no symbols. Did he build it with blocks? No, he did not build it with blocks. Now, I could be over here telling him what to say, but that's not the case. Let's see. How about x plus 2, x plus 3? X plus 2 times x plus 3. We're pretending that we're Pythagorean.
X squared.
Yep.
5x.
Excellent.
And 5.
5? Think about the corner.
1.
In the corner. So you're right. X squared 5x. What would fit in the corner? How many? Now look at him. See, you can look at his eyes and you can see what he's trying to do, where he's looking. He's looking at something. Well, there he is making it up. But in a second ago, he was looking at something remembered in his mind. Anyway, so try and see in the corner how many would fit. Would 5 fit in the corner? How many would fit in the corner?
Maybe.
If I had 2x and 3x there.
2x and 3x.
Can you see it?
Down would be the 2x.
Mm-hmm.
Up would be 3.
So what would fit in the corner?
6.
Very good. Very, very good. I was starting to think you weren't going to get it. Alright, so let's look at that real quick. Build it for me. It's x plus 2. It's x plus 2 and x plus 3. So I gave you 5. Well, let him build it. You already know what it looks like. You showed that you can do it. So now you have to build it x plus 2 by x plus 3. Pardon me. I have a spraying board cleaner and my nose does not like it. Okay, so there's x plus 2 across, x plus 3 up. Now, what goes in the corner? 5 would not fit in the corner. What's going to fit there?
3.
Well, how many 3s would you like? 2. Okay, I will get them for you. And you can do this in school or with your kids. Play banker, builder, draw, recorder. He's the banker, or excuse me, he's the builder. I'm being the banker. He has to ask me for the pieces he wants. Now, he was doing the drawing and the recording in his mind. Right? How old are you again?
6.
And how old are you?
4 and a half, almost 5.
Okay. Alright. So here we are doing algebra. So let's, I'm going to write this, actually, hey, now we just had pens. There you go. So,
can I write it down?
Brand new pens I got. It's got his thinking cap on now. Alright, what if I give you this? What if I give you this? Dun, 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 dun. X plus 3 squared, or x plus 3 times x plus 3.
Just removed the 100.
Let's take this out of here. And I'm going to put some symbols down, just for the people. You, stop. Just for the people at home, I'm going to put symbols down on the board, and they're going to be for you. Look.
Wait.
What I asked him was x plus 3 squared.
Whoa, these write pretty good.
Yeah, they write great. Okay, so tell me what we would have if it was x plus 3 both ways.
X plus 3 both ways?
Yes. How much would you have? Okay, wait, don't build it yet. Let him just do it in his mind. He already, look, he's already getting it together. Okay, an x squared.
6x.
An x squared, 6x. Okay, quick. I'll write it down. X squared plus 6x plus how many would fit in the corner?
9.
Very good.
My bear has my shirt on.
He has a shirt on his head. Took it off. Okay, wait, so it was 9 that would fit in the corner.
Yeah.
Alright, see, small, simple ones like this, no problem, right? Literally, no problem. You can do them.
Can I write the symbol down?
Now, you want to write the symbols. I know, it's getting to the point where he likes to write. Good. Now, how about we do a quick one? See, and now I'm no longer afraid of running out of space because a fine shout out to Elizabeth Stevens, who donated a bunch of money so that I could afford to get a, what do you call, terabyte hard drive. So now I can make videos as long as I want. Can you build this? If it's x plus 3 both ways, what does it look like? Has to be x plus 3 both ways. Do you need some more x?
Yeah, one more x, please.
Certainly. Thank you for being so polite. Then how many are going to fit in the corner? Singing a little math song to go along with it. Okay, so how many's going to fit in the corner?
3.
And how many 3s do you have?
2.
So you want one more?
One more, please.
Okay. I missed that. Oh well. The expression was priceless. Okay, so there you go. And now he's building it his way, but let's build it for the folks at home. Okay, so we're going to get into... And now, what are we doing here with the little kids? Again, for that, I mean, I've done this so many times. What we're doing is we are indeed just learning about multiplication and addition, add-ins for the small numbers. We're going to do some big stuff in just a second. And the algebra comes along for the ride, right? You're not necessarily learning the algebra, like I'm not teaching you how to factor polynomials. We're just playing with blocks and building these things together, right? And you know this is x squared, this is 6x, this is 9, right? So when you see 20 years ago, well, not quite 20 years ago, but going on 20 years ago, a kid named Sinaway Hardegree doing third power algebra when he's 7, you guys see this, but he sees that, right? And we've brought it home by having it so that they can get their hands on it, right? You can build it with your hands, and then later on we can draw pictures of it. All right, here's a quick picture.
Can I make it?
Here, pull off the top. Hold it. Pull off the top. Okay, here's a quick picture.
Can I do it?
You could, but speed is what we need.
I could.
And yes, you could definitely do it. And we could put the 9 dots in here. Right?
Yeah, I'm serious.
I know, that'd be silly. The faster way to do it, you'll see the kids do this. And then eventually they move to this. And then eventually they don't need it. As is evidenced by the student here who is able to just hear it and build the pictures in his mind.
And I'm also his son.
I think by now people have figured that out. Okay. Now, it's seriously, it's this important and this easy to teach the mathematics, because we can go all the way up. I don't know if you can see that. No, you can't see that. But anyway, up on the window, if you look carefully, you can see there's all kinds of math and stuff there. But it goes all the way up to the calculus. So, let's pause and come up with a really cool one for you guys to build. Are you ready?
No.
You're not ready?
No.
Okay, let's do some other kind of math. Let's do this.
I'm not ready at all.
You're not ready at all. Okay, let's do some other kind of math for a second. Let's see, right at the same time. Let's say 8.
8.
What does 8 want to be? 10. What does he need to be 10?
9. 2.
What does it need to be 10?
2.
2. Okay. But he runs into 7. Or she. Now, what do I get when I get 8 and 7 together? Tell me. What does 8 want to do? What is 8 going to do? Yep, you get a 10. Let's take the 10 and build it. See it? So he takes that and becomes a 10 because 8 wants to be 10. So he takes the 2 out of there. Can you use your imagination and see him taking the 2? Okay, so, and I'll use this right there. Boom, takes the 2. Alright, you, what's left over here? What piece will fit there?
3, 4, 5. 5.
Okay. So what do we call? What do we call 10 and 5?
10.
10 and 5 is how much? What's the name for 10 and 5?
5 and another plus 10.
Yeah.
15.
That's right, 15. Right? 5 and 10 is 15. Yes. Okay. So we're doing this. We're playing around fractions. We haven't done much fractions, right? But we do a little bit of fractions. We do algebra. We do all kinds of stuff all at once because math is a language. So the concepts are easy. Now, let's do some more. And like I said, we'll set this up and like we could do third power algebra. You want to do some third power algebra? Sure, why not? Let's do some third power algebra.
Oh no.
Are you excited?
Oh no.
Okay.
No.
Okay. Stop it. Alright, so we have a picture here. I haven't got the symbols out yet. And I'm going to have to do that for the adults. So, people that haven't seen this before. Alright, so we're just playing. Show me, what do I have here? I have x to the third. Can you show me an x to the third? Let's go around this way.
Yeah.
Have you got an x to the third you can show me? Or is x to the third? Have you got an x to the third you can show me? Okay, grab his then. Show me x to the third. Okay, so see, we played with these guys, so we know it looks like this, right? And we don't have enough room and it's too hard to shoot, so, right? I don't use those, we just draw pictures, we go directly to pictures. But when you play with your kids, you start here, you start with these. Okay, show me an x square, like a real x square, like this kind of x square, an actual x square. There's one, but show me a small one. Okay. Show me it. Okay, show me the other kind. The long x square. Very good. Right? So we can tell that it's a skinny one of these. Good. Now show me an x. Just a regular x. Do you have it? There you go. No, well, stop. Hold on. Show it to them so they can see it. Okay. Now, and that's all. That would be one of these if we were big. We're using the big pieces. But since we have small pieces, because it's already, they're small, so they can fit. So now let's count everything we have here. Okay? Count. What's this?
X to the third.
X to the third. And we only have one of those. How many x squared do we have? Be careful and count. How many x squared do we have?
0.
0. Count them all here. How many do you have?
1, 2, 3, 4, 5.
How many?
5.
Where do you see 5? Count for me all the red ones.
1, 2. 1, 2. No,
Right.
no.
You count them. How many x squared do we have here in this picture?
1, 2, 3, 4.
Okay, I'm gonna write down 4x to the second. Right? Okay. I got a little stiff talking to about how to behave a little bit while we're making videos. Alright, so we got x to the third plus 4x to the second. Now, how many x? You, get to count them.
1, 2, 3, 4.
Is that all?
5.
Yes, 5. 5 what? Gotta write it down. 5x. Okay, and how many units in the corner there?
2.
Okay. Now all we're going to do in this one, we're not going to set it equal to 0, we're not going to do anything. All we're going to do, let me come on that side. Is we're going to count the sides. So what's this side right here? That one factor. Tell me. What's this right here?
I can't.
Count it. Move up there and count it.
Okay.
What do we have?
I'm gonna check.
Okay, you check. What is it?
2x squared.
Just the edge.
Oh. X squared. 2x. And 1.
Okay, so x squared, 2x, and 1. That's just the edge. This side is also x squared, 2x, and 1, if you look carefully. Right? They're the same. Because the side of this is x squared by x, and the side of that is x, and the side of that is x, and of course the end of that, if we look carefully on there, can you point that it's just 1 right there? Right? See the 1? And then it's x that way. And over there, exactly. So we're just looking at the dimensions. Okay, so now, little boy, tell me what that side is. Going up.
X.
There's some more though. X plus how many?
1 and 2.
Oh, just up. Just going up. Just going up this side.
I might not know.
Yes, you do. How many? Count right there.
That's 2 units.
That's it. Anything hard about that?
No.
So even at the little kid age, when they see all these symbols, they make it hard. Because if we don't have the symbols and we're just talking about blocks, it's actually easier for them to look at. But once we start throwing symbols in there, ooh, something happens to the mind. And that makes it think, oh, makes it think that, oh, the math could be hard, or there should be some kind of complicated answer, right?
I know.
But the answer is not complicated. Oh, wait, now we can take x squared and 2x and 1. Can you factor that? In other words, can you make it into a rectangle?
Yeah.
Yes. Okay, get out x squared, the big blocks, get out x squared, 2x, and 1, and make me a rectangle out of it. Oh. There he is, building it. What do you need? You need a 1, don't you? Alright, here's a 1. And here, let's build it this way. The way it's supposed to be built. Like this. Alright? Okay, so now, tell me the factors of that. What's x squared, 2x, and 1? What are the two sides of this?
2 sides? X. No, x, 1, and a square.
Alright, but count them one side at a time. You're right, you have x squared, 2x, and 1. So just count and tell me what are the two sides. The one side is what?
10.
We're in base x. So the one side is what?
1x.
1x plus how many?
2x.
Wait a second. We're just counting one side at a time. You're counting both sides. So if this needs to go back in the box so you don't lose it.
Jack up the box.
Right? Okay. So if we're just counting this right here, what does she see? She sees what? Right there and right there.
1x.
And how much?
And 1.
1x and 1. So we're going to count x plus 1. Actually, that was the second factor. Now, what is it this way? Ben Isaiah.
X plus 1. Okay.
Our right is here. So it's x plus 1 both ways. It's an x plus 1 squared, isn't it?
Yeah.
So let's talk about economy of symbol for a second. You see how that's a degree. Alright, so what I said is, that's the whole rectangle, right there. Those are the sides. Now we could factor that one further if we wanted to make it into 3 dimensions. This times this times this, length times height times width if we wanted to, but why would we want to? It just makes it really hard. So first you start out here. Now, economy of symbol. Can I just say that this is an x plus 1 square?
No.
Can I?
Yeah.
Is it, well, no. Tell me. Why did you say no? Because why? Is it x plus 1 this way and x plus 1 this way?
Yeah.
Is it x plus 1 both ways? This is what that says. X plus 1 both ways. This way and that way. Now, the other factor is x plus 2. And actually, to be more correct, we'd usually put that over there. But there you go. So all we did was we made symbols. And these symbols right here tell us about that picture right there. There he is. What's he? Right? Okay, it's the masked mathematician. Okay, so really, all that is these symbols right here tell us that right there. But see what happens to poor kids in high school? You know why they have such a hard time with it? Is they never see this. They only see this. So when they look at this, or they see this, it looks all hard and difficult, just like you guys were getting a little concerned.
Yep.
Instead of just counting the side. Were you getting a little concerned?
Yeah.
Okay. Now, look at me. Where can they go for more information? Alright, let's do it, and we can do even a little bit more stuff. Okay, so here we have a new feature. Get your mask on. Dun, 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 dun. It's the masked mathematician! Okay, so what's the masked mathematician going to do? Count by tens. Okay, count by tens.
10, 20, 30, 40, 50, 60, 70, 80, 90.
Then what happens after 90? 100! 100! The masked mathematician and his faithful sidekick,
I can do it.
Cheetah Boy.
I can do it faster.
Let's count again. Let's see. Can you count by fives?
5, 10.
Wait. I know you can go, but don't go so fast.
5, 10, 15.
Hey, you, get in on the action over here. Put that stuff down.
30.
Wait. We gotta start over again. Okay, ready?
5,
5,
10, 15, 20, 25, 30, 35, 40, 45,
45, 50,
55,
60,
65, 70, 75, 80, 85, 90, 95, 100.
Boy, if I had some, what do you call it? Yeah. Do that again?
Yeah.
Okay, we got to 100. Counting by fives. Let's count by twos. I'm just kidding. 2, 4, 6, 8, 10, 12, 14, 16, 18. Oh, it would take forever. We'd be old and we'd need water and stuff to count all that way. But here's all you have to do. That's what I tell everybody. When we're counting by twos, what's the pattern we need?
2, 4, 6, 8, 10.
That's it. That's all you need to know. 2, 4, 6, 8, 10. Because then what is it? 12, 14, 16, 18, 20. And then it's always just 2, 4, 6, 8, 10. Right? 22, 24. Can you hear it? 22, 24, 26, 28. And then what? 30. Right? We're counting 2, 4, 6, 8, 10. Say it again. Say 2, 4, 6, 8, 10.
2, 4, 6, 8, 10.
Can you say 2, 4, 6, 8, 10?
2, 4, 6, 8, 10.
And then you're right. What comes next? It would be 32, 34. Then what? 36. 38. We're counting by twos. 38. 40. Right? Okay, so just start over again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Then what? 2, 4, 6, 8, 10, 22, 24, 26, 28. Then what? Wait, 30. We're counting by twos. Look where it is. Is it on the 30 or is it on the 29? It's on the 30. You can see it. So all we gotta do is practice. Practice. Let's try it again. One more time. And then let's do something else.
It takes forever.
It does when we're counting by twos. Counting by tens is way faster, huh? Because if you count by tens, it's just 10, 20. That takes the longest of all. Right?
Counting by
I have it on film where you were arguing with me that it was faster to count by ones than it was to multiply.
What?
Yes, I do. See?
Oh no.
Oh no, I know. When you guys get older.
I'm not going to watch that video for class after this.
Okay, so let's count by twos. Last time. Ready? 2, 4, 6, 8, 10. Then what? 12, 14, 16, 18, Then what?
20.
20. Then what? 22?
20.
24?
26.
28? 2010. No, wait. 30.
30.
Right?
You said 2010.
There's no such thing as 2010, right? 2010 is 30.
Yeah.
Okay. Could we count by threes? Oh, and we could count. Here's the other thing we could do. Is we could talk about how many 2s are in 6. 1, 2, right? 2, 4, 6. How many 2s do I need to make 6? Count them.
3.
Very good. What if I had another one?
2,
What if I had another one?
4, 5, 6.
Then what?
1, 2, 3, 4, 5, 6, 7, 8. 9.
It's 8. How many 2s is that?
8.
How many 2s do I have here?
1, 4.
4.
Oh, so that.
Very good. Okay. So let's fool around and just no symbols, no blocks, no anything. Tell me how many. You already know this one, but we'll just start off as a warm up. What's 3 times 3? 3 threes.
3 3s?
Mm-hmm.
9.
Got it?
We've said it lots of times in all our other videos.
Okay, so let's do something that's not. So what's 6 threes?
6 3s.
Or 3 sixes?
I would go with 3 6s.
Okay, 3 sixes. How many is that?
18.
Very good.
18.
Excellent.
I counted in my head.
I know. Okay, so no blocks. How about 4 5s? How many is 4 5s?
4 5.
Yeah.
Huh. 25.
4 5s is 25? What do you think? 4 5s.
I have no idea.
You have no idea. We'll count. You know how to count by 5s?
5,
Mm-hmm.
10,
Mm-hmm.
15.
Mm-hmm. And I said 4. So how many? 20. All right. Very good. And then 5 5s is 20. And hey, look at this.
5, 10.
5 5s is 20.
5, 10, 15, 20, 25. 25.
25. 5 5s is 25. 4 5s is 20.
Can I write down?
Can you write 25? Go ahead and try. 25. Close. That could be a 2 if you keep going. 2.
2.
20. Can you make a 5? Oh, almost.
I can do it.
You try. Make the 5.
Oh, wait, that way does nothing.
Right. That way is not.
We like the blue.
Okay. Oh. Uh-oh.
Backwards.
Backwards. And let's talk about that for just a second. Very good. Better. Try one more time. It's harder with the pen, son. You can do it with a pencil very easily.
Yes, 20.
Now, 25. And do you see when they write backwards and they read words backwards, they've got a brain that's functioning both ways. We have to teach them, and see, some kids just do it naturally, to go one way. And then the kids that can go both ways, that go both forwards and backwards, those kids get in trouble and they get labeled as being like they have a problem, when actually they're smarter than the other kids. And it's true that you'll see that kids that are dyslexic oftentimes are, if you give them a chance, they're smarter. And you know what? Some of the information from Khan shows that if the kids that have a trouble with math and whatever learning it is to start, yeah, you don't, but to start off, give them time, and then they surpass the kids that are quote-unquote normal or average, right? Because they just have to get all the things linked up in their brain for it to work. But when you're making the 5 backwards, that's the brain going the other way, right? Instead of just one way. We always teach, but see, in mathematics we go from left to right. Our symbols and syntax always from left to right. But before I get lost, see this right here? This was 25, right? Could I say that 25 is a 5 square?
Yeah.
Right? It's 5 this way and 5 that way? So remember just a second ago I had an x plus 1 square? Where'd my x plus 1 square go? You broke it apart. And we need a 1. But see, all we have there is an x plus 1 square. Yes, it's going to be naps right after this, I told you. Maybe we'll have a piece of pizza. And then we're going to have naps. But this is just an x plus 1 square. What does that mean? It means it goes x plus 1 both ways. Over here I have a 5 square. Can you build me a 2 square?
A 2 square?
Yeah. In fact, we'll let the little boy build a 2 square. You build me a 2 square, and you build me a 3 square. Quick. Build me a 2 square. He's building a 3 square. So move. We'll just build over here. Build me a 2 square. A square with 2's.
I don't know. I can't do this.
Yes, you can. This is a new stage he's going through right now. What shape is that?
Hey, see? Square.
Oh, do you have a 2 square? Yes. Put it down. Put it down. Let's talk about his, and then we'll talk about yours. So you can't do it, and he builds it in 2 seconds. What shape is that? What shape is that?
Square.
Square.
And 100.
Now, how many is in the? Is the same shape as 100?
Yeah.
Yep. Okay. So, how many in your square though?
1, 2, 3, 4.
You had to count them one at a time. Okay. Now let's look at yours. Move it over here with these guys. What do we have? What shape do we have?
Square.
Square. How many in that square?
9.
9. Very good. All right. And I'm gonna build a 4 square. Am I done?
No.
What do you think? Hey, you.
4 fours.
Do I have? Oh, I need 4.
Yeah, 44.
Okay, is that good?
Yeah.
Okay, you.
Yeah.
How many in that 4 square? Count them, please.
1 at a time.
Don't count them one at a time.
4, 8, 12, 16.
Very good. Much better.
8, 12, 16, 20.
You could sing the song, but you know that right there's only 16. Wouldn't it take forever to count them one at a time?
Yeah.
Now this is why when we do fractions and we do other kind of math, you don't want to spend too much time with big numbers that it takes forever to count. And also the other system is where they take these blocks and you gotta build a 16 square using these guys. It takes forever and the kids get bored and they hate it. They hate it. They don't want to do it anymore. Don't make me do it. But over here, boom, 16, done. Right? Over here is 25. Over here is 36. Where's 36? How many 6s would I need for 36? If it's a square? 6 6s. 3? There's 3 6s. Is that a square?
No.
Okay. How's that? The mosquito! He's pretty excited about the mosquito. We'll get him later. Sit down.
He's a crazy mosquito.
He's a crazy mosquito and he's going to die.
Yeah.
He's come into the house of math. And it will be his doom! Okay. So here is a 6. We should just open the door and let him out. That way we don't have to kill him. Let some other animal eat him. So there's my 6 square. See it? And then I'll do it for the people at home. A 6 square. And see, later on we can practice some writing, because writing is fun right now. Right? Okay. And it is, look at that, math time. Nope, sleeping time. It is time for a nap. Okay, so now let's do our big outro. Wait, put your mask on. The masked mathematician. Dun, 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 dun. And his sidekick.
Don't hold my back there.
We're gonna run out of batteries again. Anyway, go ahead.
Crewton Ramone.com.
Okay, so I asked them what they want to do. They're being bribed with a video game. When we finish this, they get to play video games. Okay. So stop. And they said fractions. Let's do fractions.
Yeah, a little fraction.
And I said, well, let's do some distributive theory also. So we're going to do fractions and distributive theory, but I can tell that we're not going to get it on film because the battery light is already blinking. Oh no! Oh no, the battery light's blinking.
Yeah.
Alright, where is Math Bunny?
I don't know what he is.
Hold on. We're filming. Stop. We have all these characters. We have the mathematician, and we have his crazy sidekick, Rooster Boy.
Yeah. No, Cheetah Boy.
Cheetah Boy?
I'm the Rooster Boy.
Oh, okay. Sorry, I can't keep him straight. You look so much alike. And then.
It's too emotional.
Yeah. Okay. So, here I have, let's do this. Here I have 10.
10.
Now I have 14.
14.
How many 14s do I have now? Okay, you.
1, 2, 3, 4, 5, 6, 7.
Wait, I already know. We're just counting 14s. How many 14s do I have?
2.
2 14s. How about another one? Now how many 14s? 3 14s. Very good.
No, not 4, 4, 4.
Can you make 4 14s? Alright, excellent. So now when I ask the older kids, what's 4 times 14? They always freak out and think, oh, it's hard. But let's do it together. What do I have here? Tell me how much is here.
40.
40. How much is here? 4 4s.
40.
4 4s. Count it.
4.
Use your 4 counting skills.
4, 8, 12. 16.
There you go. Okay, so now I know I have 40 and 16. And the next step to teach these young boys is to be able to add 40 and 16. Okay. So 40 and 16 would be 56. I'm not going to get into it here.
Can we add 2 little ninjas?
Now, stop.
I'm going to add 2.
Do you want to play games or not?
It's called Ninja Bombs.
Alright. Now, I'm going to flip these guys over and call them X.
Oh, wait,
So do you see over here I have an X plus 4?
Equal.
Do you see that?
Yeah. X plus 4.
And another X plus 4?
X plus 4.
And another X plus 4? And another X plus 4? How many X plus 4s do I have?
4.
4 X plus 4s. Now you tell me, you little boy, tell me, how many is 4 X plus 4s?
4 X plus 4s?
Hmm? What's this right here?
X.
How many X?
4.
4X. And how many's over here? Did that change?
4X.
Yeah, how much is this?
4.
Total.
Yeah.
How much?
4.
4 what?
4 4s.
4 4s. Can you tell me?
16.
16. There you go.
4, 8, 12, 16.
Yeah, 16.
Too easy.
Too easy. Why did you just say it's 4? So I'm counting everything, the whole rectangle. 4X and 16. That's easier than counting 40 and 16 because I have to add 40 and 16 together and I get 56. But here, actually the algebra is easier, isn't it? 4X plus 16. Should we write some of this down? Or do you just want to keep going?
I don't like the symbol.
No, okay, good. Now, here.
Oh, these are some strong pens.
Yeah, they're stuck together really well. They're brand new. All right, here, bring it here.
I don't like it.
Here, right here. Okay, so look, I have 4X plus 16 is the whole thing. See that? And over here, I can say, let's do the dimensions. I have 4 plus, what do I have? What do I have over here?
4 plus.
Oh, what's this? Is that 4? What's this? Just the X.
Plus
X
4.
plus
But
4.
it has a little
Now, what's this side? What's this side over here? What's this over here?
Oh, this side.
Just the edge. Where's the little man? That you were just playing with.
The man with the man game.
So we'll pause as the little men are retrieved.
Yeah.
Okay, so here, no, you can now tell me what you built. What do we have? Okay, they just finished building them. Yep. And we missed some priceless moments turning the thing off. Oops, how many X?
4X.
4X over here. What about over here?
1, 2, 3, 4. See?
So you have 4X there too. How many X total do you have? Count all the X's. These guys and those guys.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, so 8X.
12.
12? What about these?
I got a 12.
Wait a minute. We have X squared, 8X. How many units?
4.
Count all the units. You're right, there's 4s.
1, 2, 3, 4.
4 fours. Please tell me what 4 fours is.
4 fours. Oh.
What is 4 fours?
4 fours.
Yeah.
15.
How many?
Not 15 at all. 16.
16. Good. Count these, please, again.
4, 8, 12.
Wait a minute. Count them all. 4, 8.
12, 16.
Okay, you gotta count them all, because if I was gonna count one at a time, it would take forever.
4, 8, and this 12. One is...
Right, okay, wait, first, before we get to yours, we got one more thing. So we have a, what shape is this?
Rectangle.
What kind of rectangle? Let's see if I can get it so that people at home can see that.
I don't know.
Don't tell me you don't know. Tell me what you see. What shape is that? The whole thing.
A rectangle.
It's a special kind of rectangle.
Take this away, and then that's what we get.
Uh-huh.
If we take the 100 away.
So can you see, this is an x square. If I flip it over, it's 100. Can you see that this is a big square? That it's x plus 4 this way? Look, it's x plus 4 this way. And it's x plus 4 this way.
A square.
So it's an x plus 4 square.
Yeah.
It's an x plus 4 squared.
Here.
I could write that down. X plus 4 squared.
Mine
Alright, now you built a division problem because he built it for himself, and when it winds up down here, you're doing division.
Mine.
Okay, so go ahead. X squared.
X plus. Okay, it's x squared.
He sat quietly and listened while you did yours, so now you sit quietly and listen while he does his. 9x, very good. That's correct.
15.
How many?
Oh, and 6, 12, 18.
How many?
18.
18. Very good. So let's write some symbols down. Okay, look at that. All right, you can participate if you wanted to. Okay, let's look at this. You made the rectangle x squared plus 9x plus 18. And you said that going across... Oh, wait, you didn't tell me what it is going across. This guy, going across, what does he see? If he goes across here, what does he see?
He sees...
What does he see? Just the edge. Just count the edge.
X plus 3.
X plus 3, very good.
And going up.
And going down.
It would be X plus 6.
Excellent. So here's me writing it down as he was talking, and my symbols need a little work. But there it is. Okay, so here. There's that, right? There are the symbols. He's doing polynomial division. It's simple. It's easy. He'll never have trouble with this, ever.
Guess what?
Okay. Now over here, this little boy, we were talking about this. What shape did we have? We had x plus 4. See me write it for you? X plus 4 squared. X plus 4 two ways. And we counted it out, and we found that it was x squared plus 8x plus 60. Right? We wound up doing more algebra. They wanted to play with the big red blocks. Okay, so then we'll later on we'll do a lesson in addition, and we'll do a lesson with fractions where we're just doing some skip counting, right? And maybe we could do that next and see if we have enough battery to do it.
We won't.
Well, we'll see. I know it keeps running out, right? When it gets good.
Yeah.
All right. So let's do some fractions next.